Okay, so this is the last lesson of this unit. So we're dealing with rectangles with fractional side lengths. So we're going to be taking mixed numbers and finding areas, or taking areas and finding lengths of different sides. So that's the topic for today. We'll explore rectangles that have fractional measurements. So right now you're listening. If a rectangle has a side length A and B, the area is A times B, right? So, for example, if we have a rectangle with 1/2 side, the area is 1/2 times 1/2, or 1/4 square inches. So, I want to go over something before we begin. I want to make it very easy for you. Let's say that I have a rectangle. I'm going to use normal numbers, not fractions, to get your brains where you need to be. So if this length is 4 and this length is 4, you were taught in the beginning of the year to multiply the length and the width, right? So 4 times 4 would be 16. So if I asked you what's the area of this rectangle, you would tell me 16 square units. That would be the correct answer. And it's because we multiplied the length and the width, right? So let me give you another easy example. And this is more what you're going to see today. So let's just say that I told you, well, the area in here is 25. And this side here is 5. And I tell you, well, what's the area, or I'm sorry, what's the length of that missing side? So if you're given the area and a side, you would divide them. So most of you are already thinking, well, yeah, I know it's 5, right? 25 divided by that 5 is going to give you that missing side, right? That missing length. And that's what we're going to be doing today, but we're going to be dealing with mixed numbers. So we're still dividing mixed numbers. That's still the goal. That's what you need to take from me today. So this means that if we know the area and one side length of a rectangle, we can divide the other. So now here's a harder example. So now you can kind of see what I was doing above. I didn't want to complicate it, right? So if I'm given an area and I tell you, okay, well, the whole inside is 89 and 1/4, and I give you this side. Well, what you were just taught in the slide above was to divide them, right? You're looking for that missing side by dividing. So you would do 89 and 1/4 divided by 10 and 1/2. And that's what we're going to be doing. Okay. So if you open your books, you're on page 81 and we're on area of squares. So what do you notice about the area of the squares? So whenever it's a square, what you need to know is all the sides are equal. So this is 1 and this is 1. So if I wanted to know the area of this, I would do 1 times 1, right? So what you notice is they all have the same length and width, and that's because they're squares. So for number 1, that's what I want you to write. And then you're still on page 81, and I kind of just carried down. So consider this statement. A square with a side length of 1/3. So that's saying a square that has a side of 1/3 has an area of 1/3. Do you agree or disagree? And your answer should be false. No, I do not agree with that. This would actually be 1/3 times 1/3. Well, you know 1/3 times 1/3 is 1/9. So that's incorrect. That right there, the area is not that. Both of the lengths would be 1/3 to make 1/9. So you're going to write false. Now I'm on page 82. So now we're dealing with area of squares and rectangles. So on page 82, this is the diagram that I want you to try to squeeze in somewhere. It says for A, how many squares with a side length of 1/4 inch can fit in a square with a side length of 1 inch? Now, I know in your book it says to use a ruler and do all these things. If you could just sketch what you see, or if you could just really look at what I already did, you can answer the question just fine. So if I did it 4 by 4, right? So there's 1, 2, 3, 4, 1, 2, 3, 4, right? You know that there's 16 boxes. But what they're trying to get at is how many squares with a side length of 1/4 can fit? So the answer would be 16. Okay, so I just drew what the question said. And then now move down to B. So what is the area of the square with a side length of 1/4 inch? So what you do is you do 1/4 times 1/4. And you get 1/16. That's your answer. So that's how you would find the area of that square that I drew. Okay, and again, that's just a visual. Now we have a little bit more challenging of a problem, and this is what it's going to look like. It says draw a rectangle that is 3 1/2 inches by 2 1/4 inches. So if we were in the classroom, you would be doing this in groups and you would be drawing this on graph paper. I made it simple for you. I already just drew on here what you should have. So we're going to write a division expression for each question. So A says, how many 1/4 inch segments are in 3 1/2 inches? So what you're writing is technically what's in this little box right here in pink. So 3 1/2 divided by 1/4, right? Now remember that you were already taught this, but a little side note, 3 1/2. You're going to multiply these and add because we need that in improper fraction. So 3 times 2 is 6 plus 1 is 7. So technically speaking, we're going to use the fraction 7/2. So I'm going to rewrite this. 7/2 divided by 1/4. And we need to keep, change, flip. So I got 7/2 times 4/1. Now 7 times 4, you know that's 28. 2 times 1 is 2. Now, if the top number is bigger than the bottom, we divide. Well, 2 goes into 28 evenly 14 times. So that is what you will write for letter A on number 2. Okay, so now I'm going to do B. Now we have a different problem there. So the other one, we found this length, right? Now on this one, we're finding this one right here. We're finding that other side. So how many 1/4 inch segments are in the length 2 1/4 inches? So you would do 2 1/4 divided by 1/4. And then remember, 2 1/4. You need to multiply and then add the top. So it should be 2 times 4 is 8, plus 1 is 9. So technically the improper fraction you're using is 9. So this becomes 9/4 divided by 1/4. And you know that you need to keep, change, flip. So keep, change, and then flip. So 9 times 4 is 36. And 4 times 1 is 4. Well, remember, if the top number is bigger, you divide. 4 into 36, or most of you know that mentally, is 9. So your answer on that one would be 9. Okay, and then we'll finish this off. Areas of rectangles, page 83, and we're only doing the top one, I believe. So each of the following multiplication expressions represent these areas. All the regions shaded in blue have the same area. Match the diagram to the expression. So I'm going to start off, and I'm going to start with the easy one, right? So C. C is that one, right? So this is 2 by 4. That's how you know that. Okay, and then what's happening is, if I know that this length is 4, I'm going to start with D. So this side is 4, and this side is 2 1/2. So that matches this second one here. That's D. And then your next one is going to be, this is 2. And this is the 4 3/4. So that's going to be that next one there. And please label everything I have in purple. And then obviously the more complicated one is going to be this one. So 2 1/2 and 4 3/4. And that's going to be B. So come to the meet and we're going to work on the practice.